Hello, this is Lab 4 Oscillations for Physics 1, 2211. Overall, the purpose of this lab was to use the spring mass system that we were given in order to observe the energy principle and see if it is held true or not. We used the video model, which was given to us, and then we used tracker in order to track the motion of the object throughout. And then we put that data into Excel, and then from there, we used that Excel data in our GlowScript computational model. The physics principles that were used in this are Newton's second law and the energy principle. From there, we also used the velocity update formula, position update formula, spring force, and then we defined our system as the mass, rope, and earth, which means that we did not have any surroundings, which allowed us to not have to do any work calculations, which made the whole thing a little bit easier. Here you can see how we use tracker. You can see the motion of the object dotted throughout. You can see the X versus time graph and the Y versus time graphs. There's slight variation in that, and we'll get into that later. And then you can also see all the data that was used, and then this is what was put into an Excel and then later put into the GlowScript. Here is our GlowScript code. This is the first initial conditions that we have here. As you can see, we used the initial position vector found from the data here when the time started, and we also used the ball mass that was given to us in the video. On line 58 and 59, that is where our chart is put in. That's where the Excel was put in, and that's where it reads our data throughout in order to actually calculate it at each step. Here are our initial equations that we use. These establish the equations throughout the calculation loop that you'll see later. We have the spring constant, which was needed to be calculated, along with the relaxed length of the spring, which was also needed to be calculated, and those we used the energy principles and force equations in order to do that. And then in lines 88, 89, 90, you can see that's where we determined the vector direction and the orientation of the spring. And then in lines 93, 94, 95, 96, those are our initial energy values that we then use here in lines 108, 109, 110, 111. That's where we have the initial. And then again in lines 135, 136, and so on. Here you can see we also define the forces in each. We have the two forces acting on the spring, which is the force of gravity and the force of the spring. Those together add up to the total force acting on the object. And then we use those forces for the velocity update equations and the position update equation. And then those equations are then used to calculate the energy changes throughout the experiment. So it all connects pretty well. Here you can see the graphs. This is what was actually made by our GlowScript data. You can see the general oscillation in the upper left there. That's what shows the motion that the ball was going through. And then here you have in the upper right, you have the X position versus time, and in the bottom right, you have the Y position versus time. These are slightly different, and that's because our graph was not directly, our motion was not directly up and down, it was slightly circular, and then you can also see that their position is their periods are slightly different, and that has something to do with that as well. But what you can see in the bottom left one is you can see that throughout this entire time, the energy is held constant, which means that our energy principle is proven to be true. And yeah, the oscillation periods, like I said, are slightly different for the X and Y, and this is because of the slight circular motion. You can see that the X has a little bit of a longer period in the computational model compared to the Y, and then in the experiment it's just slightly different because it uses different values. So that is the reason behind that. Overall, we can conclude that energy was in fact conserved throughout this experiment. Like I said, it was held constant at 0 between the kinetic, spring, gravitational, and yeah, there was no Q value for this. We don't lose any energy throughout due to sound or thermal or anything like that, so it is held constant in that way as well. And then we can see very similar trends across the computational model and the experimental model. As you can see, they both, although they don't have the exact same values, they resemble the same shape, which is how we see the same trend. And then that means that our experimental value and our computational value both prove that the energy principle is true. Thank you.